Now, let us perform an activity to observe the diffusion of gases. Take some incense sticks and smell their fragrance. Place them in any corner of the room. Light the incense sticks. Try to smell their fragrance from a distance. In this activity, we observe that when we light the incense sticks, the scent in the vapor form and smoke mixes with the air and moves across the room to reach our nose. Finally, we learned that the movement of air, vapors of scent and smoke is known as diffusion. In this case, smoke, vapor of scent and air are highly mobile and are in the form of gases. Let us perform an activity to observe the diffusion of particles of liquids. Take 2 beakers, fill them with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Take a dropper. Now add a drop of potassium permanganate solution slowly along the side of the other beaker. Observe the changes. In this activity, we observe that the particles of potassium permanganate and water spread and mix up with each other on their own. Finally, we learned that the particles of potassium permanganate and water move. Therefore, we can conclude that liquids also diffuse with each other like gases. Let us know about the diffusion of solids, liquids and gases. We know that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. Carbon dioxide diffuses from blood into lungs. Solids, liquids and gases diffuse into liquids, and rate of diffusion of gases is higher than that of liquids or solids. Let us do a lab activity to observe the speed of diffusion of 2 gases. The aim of this activity is to observe the speed of diffusion of 2 gases. The materials used in this lab activity are glass tube, rubber bung, ammonium solution, hydrochloric acid, pieces of cotton. Take 2 pieces of cotton wool. Soak 1 cotton piece in ammonia solution and the other piece in hydrochloric acid. Take a narrow glass tube. Insert both cotton pieces separately at the two ends of the glass tube. Now close the both ends with rubber bung. Observe the changes. In this activity, we observe the formation of a white ring from the least distance of piece of cotton with HCl solution. Because the hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Thus, we learned that the both gases react together to form a white substance called ammonium chloride. Therefore, we can conclude that HCl is more dense than NH3 because NH3 travels a farther distance than the HCl in the same period of time. Diffusion of matter. The intermixing of particles of two or more different substances on their own is called diffusion. In the incense stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The rate of diffusion of gases is very high because the particles of gases travel with high speed. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than solids. There are two reasons for the higher rate of diffusion of gases. One is due to the higher speed of gas particles and another due to the greater space between them. Similarly, the liquids have greater diffusion rate than solids because particles in liquids move freely and have greater space between them when compared to particles of solids. The screen shows the difference in arrangement of particles in solids, liquids and gases. The diffusion of solid into another solid substance is negligible due to the immobility of particles in solids. The diffusion of a liquid into another liquid and that of a solid into a liquid is much slower than the diffusion of gas into another gas. The following table shows the comparison of the properties of solids, liquids and gases.
See you there.